Focus on her, OK? I get it, yeah.
Hi, everyone.
Hello.
Hello. Thank you for coming to our talk on modern testing on Android. My name is Jolanda Verhoef.
And I'm Jose Alcérreca. So let's start with the agenda of the day. But before we dive in, we need a good definition. As per IEEE 1059, testing in software engineering. What? I'm kind of in the middle of something, Jolanda.
This is the most boring agenda I've ever seen.
But developers need to find cost-effective solutions.
Hold on, seriously. How about we stop with all the theoretical stuff and we make it a little bit more practical?
I had like 150 slides of definitions, but OK, are you going to make me change the whole presentation again, really?
Yeah, sorry.
OK.
What about we start with why developers actually want to test?
Sure, I have a couple of horror stories for them.
OK, and then we can move on to the modern testing strategies. So we can talk about unit tests, UI tests, screenshot tests. We can talk about sync issues, using fakes, and maybe where you can get started.
Sounds good. OK, let's create a new app for that. What should we call it?
I'd like an app to kind of deal with the stress of being on stage. So what about we do a wellness app, and we can call it Soothe.
OK, I like that. I'll get started on building it. Let's first create a login screen.
A login screen? Why?
I've been told it improves retention.
By who?
A product owner.
OK.
OK. So I'll create a form with a couple of text fields in Compose, and I'm done.
Wow, you made a login screen? No tests? Nope. What could possibly go wrong? Let's try to figure out with our first horror story. So based on this app that Jose just built, we can wonder if anything that we did so far requires testing. And the answer to that is almost always yes. And in our case, there is a great candidate for testing. We have an email validator that tests if the email address that the user fills in is actually a valid email address. Now, normally you wouldn't write such an email validator yourself because, email addresses can be complicated. But let's say you think you're good with regular expressions.
I'm very good with regular expressions. Check this out.
Wow, that was very impressive.
Thank you.
Now, I'm sure everyone in the audience already tests, but for those daring developers that don't, let's tell a horror story. Let's imagine for a second that Jose is one of those brave developers that doesn't test. So Jose, how would you verify that this works well?
Code review, I guess.
I doubt anyone would understand it. To be honest, I don't think you even understand what's going on here, right?
Then manual testing.
Manual testing. OK, that sounds good. Let's do it.
OK, I guess I'll try a bunch of email addresses, good and bad. So person@example.com, person.surname@example.com, and the rest fail. So yeah, it seems to work.
OK, very thorough. Now you move on, you get your pull request in, and you continue with writing the rest of your app. And 2 months later, you're ready for release. So you upload your app to the distribution channels, and a couple of weeks later, you get a report from your product manager. Ooh.
Yeah. Looks like there's a problem in the UK. Did marketing forget to promote the app there or something?
Let's check the negative comments on the Play Store in the UK. Looks like Mr. Turner isn't happy.
I think there might be a bug in my regular expression.
Yeah. A lot of emails in the UK, they end with .co.uk. Maybe that could be the culprit?
Yeah. Let me try that again. .co.uk. Yeah, it fails. OK, this is really bad. So let's fix it. Push an emergency release. We're losing money, so let's now delay this with more manual QA, stuff like that. OK,
let's hope that our users update their app.
Yeah.
So 3 days later, oof, our rating is going down from 4 stars to 1.5. Can anyone guess what happened? Let's check the comments. Oh, God, I think we broke login for other users now.
Yeah. Looks like I fixed the problem with domains with multiple dots, but I broke the rest.
We got ourselves a regression. A regression is a very scary type of bug in which you break something that used to work before. And bugs are inevitable. The only way not to have bugs is to not write any code at all. But the big distinction is when you find those bugs. So if your bug is fixed in the early stages of development, it's actually not a big deal. Like, you quickly fix it, you continue with your work, everything's fine. However, if the bug's discovered by your users, it's going to take you and your colleagues a lot more effort to get it fixed. So tests don't magically uncover all the bugs in your code, right? But sometimes they do, and it feels really, really great, because the tests make you think.
Yeah, so if we had unit tests for this in our example, when fixing the bug, we would simply add a new test case to the already existing list. And we would automatically run all the tests, catching the regression for sure.
Cool. Let's continue with our second horror story. So this time, I'll be the brave developer.
So I'm the smart one now. Yeah, OK.
So our form is done, and it's quite simple. So do we think we need a UI test for this?
Yes, I'm pretty sure we should.
I'm pretty sure I can just grab my phone and test it in 10 seconds.
Sure, but you probably want to test it in a very small device as well.
I have an emulator for that, right?
Yeah, well, and a tablet.
OK.
And a foldable. Remember to test all the gestures and the interesting positions.
Fair enough.
And you have to do this all over again in dark mode.
Yeah.
And using a huge font. Remember that a lot of users need large letters.
OK, and then I guess we also need to test it in every single language?
Well, right to left for sure. Japanese, why not? And of course, German. I'm so glad you got that joke. So verifying your app in all these different states can be extremely time-consuming when done manually, and mistakes are easily made. However, you can automate this with UI tests. We'll show you how to create them in a later section.
So now that we've seen the hard way why we need to write tests, let's dive in and define some good testing strategies. Before we do that, there's an important distinction that we have to make. And when we're talking about testing mobile app code, we can talk about local tests versus instrumented tests. First, local tests run on your developer's machine. So whenever you run your tests, the test code is executed using the Java Virtual Machine, or JVM for short. In contrast, instrumented tests run on an Android device, either an emulator or a physical device. The app under test is installed, and then a test APK is uploaded, and the test code is run. The results are then communicated back to your developer's machine. Generally speaking, local tests are faster and smaller. They don't have to wait for an emulator or a device to run. In contrast, instrumented tests are bigger and generally slower. However, they do give your tests a higher fidelity. And what I mean with fidelity is that the test is more realistic, and it is closely resembling your production situation of your app. Both of them serve their purpose. So let's start with the smallest type of test that we can write, and that's a local unit test. The unit test is, for example, the email validator that we saw before. We're just testing that one email validator class in isolation without any other dependencies. An integration test is a little bit larger. It verifies that multiple components work nicely together. They can sometimes be run locally, but they can also be run on a device. UI tests verify your app's user interface, and they can be broken up into semantic UI tests and screenshot UI tests. Semantic UI tests validate the properties of your UI, while screenshot UI tests verify that everything is pixel perfect. And we'll go into much more detail of those later. Now, performance tests verify that your app performs in different scenarios. They need to be run on an actual device, because only a real device will give you a realistic picture of the speed of the execution of your app. If you're interested, there's a lot of interesting talks during this conference on performance. And a personal favorite of mine, accessibility tests. You do want to check that your app is accessible, and you can do that in an automated manner as well. You can test for content descriptions, touch target sizes, color contrast, and more. So let's first dive deeper into unit tests and integration tests. Jose, can you explain a bit?
Yep, let's start with unit tests then. So this is a dependency graph of our app. The email validator, as you can see, has no dependencies. So this means it can be tested in isolation. This is the simplest test possible. As we saw before, we can just call a method and verify if the result is true or false. It's very easy to scale. Obviously, you would never do this way. But the point is, it's very easy. However, we often need to test classes that depend on other classes. For example, the login view model depends on the email validator. In that case, we can replace those dependencies with test doubles. Test doubles are objects that look like the real dependencies, but we can control from the test. In most cases, we replace the dependencies by fakes or mocks. So let's talk about that. Fakes provide an alternative implementation of a class that allows for easier testing. You normally create them manually. Mocks allow you to also create expectations about the interactions, so you can verify that a method was called. And for that, you normally use a framework like Mockito or Mock-K. If possible, use fakes, just for simplicity. So when testing our login view model, we can pass a fake email validator. And when creating this fake, you can design it so that you pass a Boolean, making it always return true or false. Then in your test, you pass that fake validator to your view model. And then test the behavior that you're interested in. In this case, we make sure that when the email is valid, the UI state exposes no errors. And then you might be thinking, why don't you just pass a valid email address? That way you can cover your real email validator as well. Well, long story short, this is a unit test, and you want to cover the smallest possible piece of code. The reason is that if you see that the other class is covered, you might think it's unit tested, and you might forget to do it properly. So always try to keep it unit. So that was also relatively easy. But how about this? Let's imagine we want to show a system notification when the user successfully logs in. I don't know, marketing decision. That notification is shown from a class called Auth Manager. And we have arrived at the other side of the spectrum. Auth Manager depends on an Android platform class. So it would be hard to fake or mock the notification manager, and it wouldn't be very useful anyway. So one way to test this is using Roboelectric shadows. Roboelectric is like a super big fake, or collection of fakes. They provide a local implementation of the Android APIs, replacing some parts, but providing a realistic behavior overall. Roboelectric is a Google library, and some apps base all their testing strategy on it. However, before using a Roboelectric shadow, consider if it's the right approach. You might be able to find a way to refactor your code so that you don't need it. I've seen a lot of Roboelectric tests that had problems in their architecture, but they didn't really need Roboelectric. But we'll talk more about that later. So we've covered unit tests. Now let's look at integration tests. As Jolanda said, they are larger and verify that two or more components work well together. So coming back to our app, what if you need to verify code that it's tightly coupled, not with Android, but with a library? Well, luckily, libraries are getting much better when it comes to testability, and Jetpack is no exception. For example, the navigation library provides a test artifact that lets you navigate to a destination at any point. Another example is Room, which provides an in-memory database that is perfect for testing. And there are a lot more, so always check the testing section of the documentation for the library that you're using. A library that has a very, very powerful testing artifact is calling coroutines. And this is a topic that we won't cover today. But if you want to learn more about that, our colleague Martin Brown is giving a talk tomorrow at 9 a.m. titled Untangling Coroutine Testing. So don't miss it, but if you do, check out the documentation because it's really comprehensive as well. So you normally run integration tests locally, but you should also consider doing these as instrumented tests so that they use the real implementation. A good example of this is verifying that your app works, or at least the database part of your app, works with all versions of SQLite. Because every Android release comes bundled with a different SQLite version, you can run the same test on different devices or emulators, running on different API levels, and then running on different SQLite versions.
Great. So we've covered unit tests and integration tests. Let's continue with UI tests. I'll take on semantic UI tests, and then Jose can do the screenshot UI tests. So semantic UI tests, what do I actually mean with that? In general, each semantic UI test starts by rendering some part of your UI. So for example, in this case, I'm rendering the email address and the password field and the login button. Then we can decide to validate properties of that UI, semantic properties, which mean that it's properties that say something about this UI. In this case, we're verifying that our button is in an enabled state. We can also choose to interact with the UI. And interaction can be like filling in an email address or clicking that button. And then after we interact, we can again validate properties. So we can validate that certain properties actually changed. And this cycle can continue multiple times. So we can do a lot of these interactions and then verifications if we want to. That does mean that we get differently scoped tests. So a small test would just render a tiny piece of your UI and validate certain properties on it. A medium test could render a full screen and then do one interaction and a verification. And a largely scope test can open the whole app and go through multiple screens. So let's show this with a couple of examples. So in the small scope test, we could just render one text field that we have, pass it an error, and verify that that error shows up correctly. The medium scope test could start the whole login screen, fill in an email address, press the button, and verify that an error is being shown. And the large one could open up the whole app, fill in a valid email address, password, click the login button, and continue going throughout the whole app. So let's try to implement those. We can actually use either Compose or the View system. For Compose, we will be using the testing APIs. For the View system, we will be using Espresso. Now, this is modern testing on Android, so let's use Compose. We'll start by creating a login screen test class with a test in it and with a Compose test rule. And inside our test, the first thing that we're going to do is render a piece of our UI. In our case, we will be rendering the login screen. Then we can interact, or we can verify. In this case, let's start with a verification and start by saying we're checking if the button originally is enabled. Then we can interact, filling in a wrong email address. And after that, we can check that now our login button is actually being disabled. So where do those tests live? We have the local versus instrumented division. And in this case, by default, we would be adding our code to the Android test method package. We can also decide to put it in the test package. And that's the difference between putting it instrumented or locally. So when it's in the Android test directory, it will run as an instrumented test on your device. If you put it in the test directory, it will run as a local test. However, running this as a local test is kind of weird because we don't have an actual device rendering a UI. And this is where Roboelectric comes in again. So using the Roboelectric test runner, we can use Roboelectric as the big fake that actually then locally renders our UI, and we can do those same validations. So in the end, our test is exactly the same whether we run it locally or as an instrumented test. OK, so let's put this on our overview. So what we have is Compose testing APIs to create those tests. And then if we want to, we can use Roboelectric to run them as local tests. And if you're in the old View system, you can also use Espresso to do these same kind of tests. OK, screenshot testing.
All right. Although the semantic UI tests that Jolanda explained are very powerful, they can't test everything. With Espresso in the view world, you can access any property of any view in the hierarchy at any point. You can even know what class a specific view is. But Compose has a different approach to this. It uses something called the semantics tree, which only exposes certain data, such as the text of a composable, its size, whether it's clickable, focusable, etc. Because Compose uses composition over inheritance, there's no concept of a composable class or a background color property, at least that we can verify from tests. So how do we verify that our login button has a green background? Well, you could use the test tag modifier, but don't. To bridge your UI with the test, we can give it hints about those visual properties, like background color, elevation, corner radius, etc. But then you would be testing the code that sets that tag, not the property itself. It gets a little bit better if you create your own semantic property, because this is type safe, but it would have exactly the same problem. You're not testing the property itself. A better approach would be to use screenshot testing. The way it works is you start a test that shows a screen or a composable. You take a screenshot of the part that you want to verify, and then you compare it against a previously approved image. We call this image a golden screenshot, or a golden image, or a baseline screenshot. That way, when you make a change to your code, your new UIs are compared against the previous image, and one or more tests will fail if there's a change, forcing you to approve that change in a very easy and visual way. This is also a great time to bring your designer and make sure that everything is pixel perfect. To take this screenshot, make the comparison, and show the results, you need a framework. Normally, it's a Gradle plugin or a cloud service that has some web interface. In the past months, the community has been filling this gap, and it's become a very exciting area with lots of developments. So doing this on devices with instrumented tests is great for compatibility testing to make sure that your UIs look perfectly fine in your users' most popular devices. As a side effect, it also produces a very nice catalog of screenshots that you can share with your product managers or UX team or maybe the QA team so that they have to do less manual, to reduce the manual work. There are multiple libraries to do this, like Shot from Pedro Gomez, or a new one called Dropshots from Dropbox. Once set up, they're very easy to use. In this case, for Dropshots, you just add the Dropshots rule, and you just call some method passing an activity and a screenshot name. So that's instrumented screenshot tests, but turns out you can also run screenshots locally. And this is great for regression testing. For that, you can use a neat plugin from Square called Paparazzi. Paparazzi uses the same library that Android Studio uses to create the previews, which does not require an Android device. And this, in theory, makes the test fast. But the most important thing is that it makes the test cheap, because running on devices can get really, really expensive. Obviously, this is limited by the fidelity of the rendering library, which is called layoutlib, although I think it's way more than enough for regression testing. Another problem with Paparazzi is that it relies on layoutlib, but layoutlib is not a public API, and they're doing very smart things to get it to work, but it's not supported. So take that into account. I don't think it's going to break anytime soon, but I had to mention that.
Thanks. So all of the UI tests that we discussed, they share an issue. So when you're running your app's user interface, sometimes you need to wait for things to load or animations to finish, and that can cause some synchronization issues. So let's take a look at those and how we can solve them. Remember our email validator from the beginning of the talk. We decided we don't really want to risk any more bugs with it, so we decided to move it to our server. And now we also changed our app so that it shows this little loading spinner while it is validating the email and before it's showing the error. However, the test that we wrote before is now failing, because it's trying to get that node with text login, but it can't find it because it's just showing that spinner. So in general, we need some way to tell our code that it needs to wait for this UI to kind of settle down. When a test launches a UI, it needs to wait for it to stabilize. Then it can run some actions, like clicking a button, and then again it has to wait before it can do any more assertions or actions. And this is what we call synchronization. Espresso and Compose out of the box come with a lot of tools and automatic behavior around synchronization. So normally you don't really have to worry about this too much. But there are some situations in which they don't know. So for example, when you're doing a network request, how does your test framework know how long it should be waiting for? And also consider that background operations or coroutines are invisible to your test framework. So you will have to deal with this yourself in some way. We will talk about 3 different mechanisms that we can use to deal with synchronization: idling resources, waiting for things, and removing problematic components. First of all, we can use an Espresso feature. It's called idling resources, and it helps you to explicitly tell the test that the app is idle or not. So let's look at our authentication repository. We can register a simple idling resource, and then when we do the network call to log in the user, we set that idling resource first to busy, and then when we're done, we reset it to idle. I took a lot of shortcuts here, so if you want to learn more about this, go to Google/Espresso idling resources, and you can learn much more. But ideally, you don't really have to configure those idling resources yourself. For common situations, you can use an idling resource from a fake or from a test double. A good example of this is the RxIdler library by Square, which wraps RxJava schedulers and does all that setting to busy and setting to idle for you. Another way to deal with synchronization is to wait for things to happen. So for example, in the test that we had, when we click the login button, we should wait for some time, and then we verify that the login button is indeed disabled. Now, the worst thing you can do here is to make your test thread sleep for a while, because these tests will be slow or they will fail, and it's really impossible to get that number right, and you will actually let your tests wait that amount of seconds. So you'll see tests failing, and you'll never really figure out why that is happening. There is a better way to wait, and it is part of the Compose APIs. there's a method called waitUntil in the API, and what it does is on every frame it executes its body until that body returns true. And only when the body returns true, it actually continues with the execution of the rest of your test. This is great when you're doing big end-to-end tests, but you should be careful when you're using this. It should only be as a last resort when necessary. There is also a proposal to make this API nicer that is currently being worked on. And you would be able to wait, for example, until a certain node exists in the tree. So the 4 lines that we had before will only be 1 line of code. In the meantime, there's a blog post that Jose wrote on this topic on Google/Compose testing. And if you open that, you will get some nice copy-pastable versions of these methods. Now, instead of dealing with this problem directly, you can also decide to remove and replace your component that is causing the problem. So if our email validator lives on our server and we don't want to wait those seconds for that server call to happen, what we can do is we can simply replace it with a fake email validator. It's close to what we did with the unit test, but now that we have a bigger UI test, using test doubles isn't as trivial. So the 3 solutions that we discussed, they are all sometimes necessary, and you should consider on a case-by-case basis when you would be using which one. The testing documentation contains more information in case you're interested. And right now, we'll spend a bit more time talking about number 3, replacing our components. Jose, can you explain how we can use these?
Yeah. So when you start an instrumented test, you're not in control, in principle, of the creation of any of the components. In this example here, we're just telling the test which activities to start, but probably you want to avoid fetching data from the network in a test or use fake data so that you have control of what's going on. So how do you inject your test doubles? Well, this used to be quite cumbersome, but it has gotten a lot simpler with Hilt. Hilt made setting up dependency injection in an app almost trivial, especially if you follow the great documentation. Because Hilt is very opinionated, it comes with tools for testing. You can replace modules just by using a couple of annotations. So let's see how that's done. First, you annotate your test with Hilt Android rule, Hilt Android test, and create the Hilt Android rule. Then let's say you want to replace the auth service that our login screen uses. It's provided here in the authentication module. So to replace this service, we will replace the whole module for another. So how do we do this? Well, in the test source set, we can simply create a fake authentication module that provides this fake service. And then we tell Hilt that it should replace the authentication module in every test. And that's it. All your instrumented tests are going to use this fake instead. Obviously, you can also replace a specific module for only a specific test and do other things. So check out our documentation for more features.
OK. I can understand that you might be a bit overwhelmed with all of these different types of tests that we covered today and all of these use cases. So let's try to come up with some actual practical next steps that you can take in your code base. Keep in mind that these are just our suggestions. You might want to take a completely different approach based on your project size, complexity, or any other factors. It's not a one-size-fits-all solution. We get that. But what we would suggest is, as a first step, it's not really about testing, but make sure that you actually write proper code and testable code. If you follow our new opinionated guide, architecture guidance on developer.android.com, you will automatically use code that has been designed with testability in mind. Second, you should consider configuring a CI service. So if you work in a team, you're probably used to working with some sort of a version control system, such as GitHub or Bitbucket. And when you make a code change, you create a pull request, and your colleagues can check that your work is valid. Our CI service acts as an automated colleague. So whenever you create a pull request, the CI system checks out the change, and it runs any automated checks that you have configured. The basic verification that you should run on every pull request is that your app still builds, because you might have done a merge and there was like an import that you were missing, or you forgot to add a file to version control or whatever. And if you have them, you can also use this moment to do any local and instrumented tests. Nowadays, CI systems are quite easy to set up. So GitHub Actions might be the most popular one, but there's also Circle CI, Travis, Bitrise. You can even set up like a super powerful custom one with gCloud or any other cloud provider. So with your CI set up correctly, what's the next step? Unit tests. Yeah, if you follow our guidance on architecture, there are some classes that are quite easy to unit test or should be easy to unit test. In our UI layer, we have stakeholders, view models, for example, or presenters. And then in our domain layer, we have use cases. And in our data layer, we have repositories and data sources. And all of these normally can quite easily be tested in isolation using test doubles. Now, while you create these tests, you might not really find any bugs, right? You might, which would be awesome, but probably everything will probably already be working. But you will catch regression bugs in the future for sure. And as we saw in the intro, that is quite valuable. Our fourth recommendation is to use Paparazzi that we just discussed and an extra library called Showcase. And this is specifically for when you already write some Compose code and you have previews. Because what Showcase lets you do, it lets you automatically create screenshot tests for every preview that you have in your app. So it is a quick win, right? Like it's not it will not fix everything, but it will be a nice quick win if you already have those previews. Our next recommendation is to write smoke tests. So that's the large scope test that we discussed before in the semantic UI tests section. This will just be a couple of tests that go through your app from beginning to end, testing the happy flows. And this will help you to figure out that your app actually is going to crash. So you will never publish a crashing app, at least not for those happy flows. That is actually quite valuable. The sixth step is to write tests for every bug that you find. So, when in production we find a bug, before actually fixing that bug, what we can do is we can write a test for that fix. So, for example, for a .co.uk scenario, we can write a test. Now, that test would fail because of our bug. So the first thing we do when we fail, we fix our email validator, we fix our test runs, we're protected from regression bugs. This can never break again. This is a common pattern, and it will help you to test those parts of your app that are most vulnerable to bugs. Now, last but not least, you should test the rest of your app. Like, we've taught you the basics now, and it's up to you to finish it up. Check out our documentation, code labs, look around in sample codes, do some research on other teams and how they do their testing or how they enforce rules, etc., etc. Now, your goal should be to increase your test coverage to a point where you're happy, to a point where you can be almost certain that you're not just gonna add bugs in production. But don't get too obsessed with getting to 100% of coverage. Start with the parts that contain the most business logic and work your way from there.
OK, so to wrap up, if you want to get started, we have a lot of resources for you. First, we released new official documentation earlier this year, including opinionated content on what to test, different types of tests, test doubles, etc. We also updated the testing tools documentation, where you can find all the Gradle configuration and command line parameters related to testing. If you're using Compose, things are quite different and much, much better for testing, because Compose was designed with testability in mind. We created a testing section in the Compose documentation, so check it out. It features my face and also a very handy cheat sheet that gives you access, that gives you a very good idea of what you can do with Compose tests. If you're using views, Espresso also comes with one. If you want to start testing right away and prefer a code lab, we have that for you as well. There's the Compose testing code lab, and there's other testing-related code labs which haven't been migrated to Compose yet, but obviously there's a lot of content, a lot of good content there if you need step-by-step instructions.
OK, with these steps, our journey to modern testing on Android can start. So now what? Well, if you don't test yet, then we hope that this talk inspired you to start, right? And if you tried testing in the past, but you were discouraged by flaky tests or hard-to-write tests, we would ask you to consider again. Things improved a lot. We got a lot more documentation. We got libraries that were designed with testability in mind. And we have Compose, which made things a million times better. Also, if you need another excuse to migrate to Compose, testing would be a good one. And if you already test, which of course all of you do, we hope that you learned something, but also become the test champion of your team. If you see a PR that doesn't have any tests, flag it, invest in making your CI faster, organize hackathons, everything. Because testing leads to happier users, and that's our ultimate goal. Thank you.
Thank you.